Hello everyone, welcome to STAAD Pro tutorials. Today we will going to learn how we can apply the basic different types of load in a building and how we can calculate that loads in particular building. As we know, there are basically three types of loads which we consider in the building. These are the dead load, live load, wind load and the earthquake load. First two, the dead load and live load, they are the static loads. In dead load, all the permanent loads like weight of the building, mass or any structure's weight is considered. The live load is weight of everything that is superimposed or the weight of any movable structure like weight of persons or anything, it's considered. We have Indian standard specification for different types of load if you want to refer that. For dead load we have IS 875 part 1 for codal provision, in which the basic building materials and unit weight of the various materials are provided. In live load, for the different categories of building, how we can consider the live load, that is mentioned in IS 875 part 2. The wind load and earthquake load, these are the dynamic loads which changes with the respect of time. So that specification is also available in IS 875 part 3. In the earthquake load, IS 1893 2002 code specification is available. Today we will consider the basic building loads, that is dead load and live load, and how we can apply that loads we will understand in the STAAD Pro. Now let's start. I am considering a simple building frame for analysis purpose so that you can understand how we can calculate the basic building loads. So let's start with the space. I am considering a simple frame for understanding when a building design. Let's go with the structure wizard part. So let's start with the structure wizard part. To select, I am going to select one simple geometry from the structure wizard part, which is available in the frame models. We will consider a bay frame. Let's consider a simple bay frame having height of 3 meters. I am considering only the first floor parts so that you can understand how we can apply the loads. Okay, we have number of bays along height, only one. So I'm considering a simple frame so that you can understand how we can apply the basic loads in the building. Let's merge this model with the STAAD Pro. Okay, so now consider this building and we will apply some basic properties. Let's consider this as a ground floor, and then now we will apply some property. Let's consider the property part. We'll apply a rectangular section of 0.45 by 0.230 for the column and 0.350 for the building, that is beam. So we will apply this for the column, 230 by 450 column. Let's select beams parallel to Y, assign to selected beams so that I can assign this. Now let's go for the beam part. We'll analyze the beam accordingly and let's select this. So I have select in the elevation part, you can see that all the beams are selected. So we'll assign this as a beam part. So we have assigned the columns and beams, and let's assign the support. We'll go for the support, create, we'll assign the fixed support. I'm going to the elevation part. I have changed the cursor to the node cursor so that I can assign the supports to each of the members. Now, so this is the basic geometrical part. We have considered this. Now let's start how we can calculate the loading part in the building. So let's first understand what are the loads incorporated in the buildings. As you can see, the basic loads which we are considering, these are the wall loads, internal or the partition wall loads, floor load, that is slab load. As I have mentioned earlier, that we will not develop the slab or we will not model the slab as a plate element in the STAAD, but instead we will apply the slab load as a floor load. And if we have any cantilever part, then also we can calculate. So the basic loads which we have to calculate, that are the wall loads and the floor loads. So let us first understand how wall load is calculated. So we have to calculate the wall load. the basic density or the unit weight of brick is 19 kilonewton per meter cube. So I have calculated the wall thickness into wall height and the unit weight of the brick. So basic wall thickness available is 230 mm, and I have minus from the clear height, that is the floor to floor height is 3 meter, and I have minus 0.350, that is the beam width. That means whatever the beam we have selected in the geometrical part, so I have to minus that particular depth part of that section. So I have minus that depth from the clear height 0.350 meter. So this is how I can calculate the wall load 11.58 kilonewton per meter. In a similar manner, if you have the internal wall, you can calculate this wall thickness into wall height into unit weight of the brick. In a similar manner, we have to calculate the floor load. Right now I have considered density of concrete as a 25 kilonewton per meter cube for the slab part, and the thickness of slab is 125 mm with extra 1 kilonewton per meter square floor finish. So that's why we can calculate the floor load as a 4.125 kilonewton per meter square. And if we have any cantilever part, then you can simply multiply the floor load into that length of the particular cantilever part, so that you can calculate also the loads on the cantilever. So this is how we will consider one by one load in the STAAD Pro. Let's consider this. Now in this particular model, I have considered the outer element, outer boundaries, or let's say I am opening this particular floor. If I want to know this floor, I will go for the options, selecting a whole structure, that is a particular floor, and right click new view. We have the option for creating the same window part, so only that much floor is available. Now I am considering all the outer walls as a main wall. So these are the walls which we will consider as the main wall. The thickness is 230 mm, and the rest of the wall we will consider as the internal wall load. So in the periphery line, that which are the beams I have selected, and that particular part I will apply the wall load in the form of 230 thickness, and the rest of the beams, that is the internal beams or the partition walls, we will consider in the inside part of these structures. So let's start with the STAAD Pro. Let's go to the general, load and definition. We will develop one case. This is the first case, the dead load. We will apply the dead load case. First of all, we have to apply the basic load, that is the load which is the self weight in -1, so that it will calculate the self weight. We have to apply this to the whole structure. I am going to assign to view. So self weight is assigned. Now next part is the wall load. So we have calculated the wall load as 11.58 kilonewton per meter. So I will apply minus 11.58 kilonewton per meter. Add. Now let's understand how I am applying this load. I will go for the floor part, right click new view. I am considering all the outer beams for the main wall load. Okay, so we can go for assign to selected beams. Okay, so you can see that I have applied the all wall loads for the outer periphery, in which we will consider the 230 mm thickness wall. Now let's go for the inside wall. Now we have separate options available for in the selection approach. We can go for the inverse beam selection. We have inverse beam selection. This command will allow us, means right now whatever the beams I have selected, it will reverse the selection part. So you can see I have selected the reverse beam. I will go for the right click new view. So I have only the internal beams or the internal walls where we apply the internal wall load. So what is the internal wall load? It's 5.79 kilonewton per meter. So we will go for the member load again, minus 5.79. Let's consider 5.80. Add. I'm going to assign to view. So this is how I have applied the basic wall load. As you can see, when I click on the 11.58, the blue color is highlight. That means it is the assigned load, and the rest of the loads are in the green part. So when you click on the particular load, it will highlight with the blue color respectively, and the rest of the one are in the green form. Shift V you can press and you can see the applied load in the prescribed form. This is the shortcut for the loading part. So we have applied the wall load. Now let's go for the floor load or the slab load. So let's go with the slab load. We have to apply as a floor load. So I'm going for applying floor load. Floor load we have calculated using this thickness 0.125, considering 0.125 thickness with the 25 kilonewton per meter cube load, and let's consider this as 4.125 kilonewton per meter square. So we will go with the 4.125 kilonewton per meter square minus 4.125 kilonewton per meter square. Y range I am specifying. We will consider ground plus 3 storage. So let's apply the 15 meter right now for understanding. So this is how the floor load is applied. So all the basic loads are considered in this part. That is the weight of the wall load and weight of the slab. The weight of beams and columns will be calculated by STAAD using the self-weight command. We have applied the self-weight command, so the weight of walls and weight of beams and columns we did not need to calculate. It will calculate it using the self-weight command. It will calculate automatically. So we have applied the basic loads. Now let's go with the second load case, that is the live load case. We'll go for the second load case, live load. Live load command. Now understand, live load is a movable part. We will consider right now the live load as a 2 kilonewton per meter square. You can go for the 4 kilonewton, or you can refer the IS 875 part 2 for the variations in the live load. Right now I'm considering live load as 2 kilonewton per meter square. Add. Please remember that it will change the live load for depending upon the function of your building. You can refer the IS 875 part 2 for the different variations. Right now I'm considering minus 2 kilonewton per meter square. Live load is also applied in the form of floor load. We will apply the live load in the form of floor load. So this is how the floor load or the live load part is applied. So the basic building part or the loading part is considered in this. I have considered one floor only. So now you can apply the translation repeat command. So all the loads are also repeated again with the respective translation repeat. So the basic loads are considered, like this, the dead load and live load. Now we can go for the translation repeat command. Now let's go for the translation repeat. I will apply in the y direction for the 3 meter height with the, let's consider 2 steps. We do not require to go for the link steps because already we have selected the columns with the property part. Okay, now what's the problem is the fixed supports are also transferable. So if you want to remove the supports, we have all different specifications available in the support part, that is the no support. So you can remove the supports using this command, assign to selected nodes. Okay, so we have removed the support. So you have to take care about that particular part, or either you can go with the link step and copy the floor only. So this is how the loads and definitions. Let's check first whether it's applied or not. You can see self-weight is applied only to the ground floor only. Wall load is applied to throughout the structures, same way as a partition wall load. So we have to apply the self-weight. You have to check first whether the all load cases are applied properly or not. We'll go for the assign to view for the self-weight command. In crack, it sometimes happens that it will not consider self-weight to the transferable part. So this is how we have applied all the basic loads. Let's check first. Okay, so floor load is also applied. Now the basic, we will consider one basic combination for that, is dead load plus live load combination in the command loading, an automatic load combination. For the, when we go for the combinations, it will ask for the code, general structures, generate loads. So it has generated basic load combinations for the dead load and the live load part. So this is how you can also generate auto load combination. You can go for the manual load combination also. Now we can analyze this building particular. Okay, so this is the simple building, so that you can understand all the basic loads, how we can apply this. And now I'll go for the command analysis, perform analysis. So this is only analysis part. Now if you want to go for the design part, you have to go with the design tab. We have several specifications available in the STAAD Pro for specific design. So you have to go for the design. We'll go for the concrete. We have to select the code, select IS456 for the design code. Now we have separate parameters available in the define parameters part, where you can go with the number of variations for the cover part, that is your yield strength part of the concrete, and different scenario which are used in the design parameters, like that is the clear cover of the concrete, grade of concrete, and maximum or minimum bar specification. These are the several specification available if you want to design a building with the specific different parameters. Right now I am not considering these parameters. We will understand these parameters later on. Right now I am going without parameters. I want to show you that if you do not provide any parameters using this, STAAD will automatically consider minimum requirements as per IS456. So right now we will not defining these parameters. We will understand this later on. Right now I am considering only commands, and without providing parameters we will only provide the command for design beam and design column. And the third part available, that is takeoff. Takeoff will calculate the volume of concrete and the required bars of the steel. So I want to show that if you provide only commands for design beams and columns, it will check according to the codal provision of IS456 and design it automatically. So we will consider these command parts. We'll go for the design beam. I'm adding the parts. Design column. Right now we do not have developed any slab over here. We have applied the floor load, so we will not consider the slab part. We'll consider the takeoff. Takeoff will calculate the volume of concrete and steel, quantity of steel. So let's go with the design beam. We will select all the beams for applying the design beam command. Assign to selected beams. Okay, so you can see all the beams are selected. Select beams parallel to Y. Okay, so for applying the design column command, we will go for the select beams parallel to Y, and you can assign this to selected beams. Okay, concrete tech is automatically assigned, so we have only applied the design beam and column command. Now we will go for the analysis part. Command analysis, perform analysis. Okay, analysis run. Now let's see what STAAD will design for this particular codal provisions. We will calculate each of them. Now you can see that we have one warning regarding the floor load. When you apply the floor load as a slab for the slab, if you will find always one warning, that is warning regarding to the floor load command. Let's see what is the warning. Okay, so the warning is, please note that depending on the shape of the floor, you may have to break up the floor either one way or two ways. So you will always find this warning because we have considered all the parts in the form of two-way slab form. You can go with the one-way form, so it will always show one warning regarding the floor load. Means depending on the length, you have to break up that part. Now see, let's go for the output parameters. Post-processing mode is activated. You can find the displacements over here for the nodal. Beam relative displacements are also available for each combinations. You can go for the beams. We have stress and forces value available for each beam values. Okay, so let us understand how the output has considered the design part. So we will understand today the design part of the. Okay, so let's see beam 1 design results. See, STAAD has considered M30 grade for the design parameters. Fe415 main steel, Fe415 secondary steels. It has provided the cover of 25 mm for the beam. Now the summary of the reinforcement area is provided over here or shown over here. So you can see that the beam number 1 has a 3 meter length, and it is distributed with top and bottom reinforcement. You can see I'll I'll show you one sample of the beam so that you can understand. Let's consider one of the beam part. Right click new view, we'll highlight the bending moment diagram. Right now I have considered the bending moment diagram. Results, view value, beam results, and okay, you can see the for the according to the deflection we have the negative bending moment diagram at the support part, at the support junction. Okay, so STAAD has divided reinforcement accordingly. You can see that a 3 meter beam length has the negative support reinforcement of 175 mm square. In the intermediate part there is no reinforcement provided. So this is basically considered. We have the negative moment, so it has considered the negative part in the STAAD. In the bottom part you can see that deflection is more and bending moment is also more, so it has considered reinforcement in the mid part, but at the end part of the bottom reinforcement there is zero reinforcement provided. Depending upon the area of steel required, they have provided the reinforcement area or the steel. This is a summary of provided reinforcement, which is based on this required steel 175 mm square. They have provided two numbers of 12 dia continuous bar of one layer. Layer indicates the number of bars in each line. In the bottom part they have also provided two numbers of 10 dia bars of one layer, and for the shear reinforcement or the distribution steel we can say that 2-legged 8 dia stirrups at 110 mm center to center spacing. So this is the reinforcement details based on the shear force and bending moment calculations. You can see minimum two numbers of, right now you can see in the top reinforcement part, in the intermediate part there is no requirement of the reinforcement or the area of steel. Still they have provided minimum two numbers of bar, because for providing the stirrups you require minimum 4 number of bars at each corner. So this is how the reinforcement details are provided. Let's go for the column details, how the column details are provided. We'll go for the column. Okay, so here column details are required steel area is calculated. They have calculated concrete area. Main reinforcement is provided 8 numbers of 12 dia bars with the tie reinforcement of 8 mm dia rectangular ties at 190 mm center to center spacing. Section capacity or the calculated load for which they have calculated the steel is provided. This is the force and this is the required moment. So this is how you can go for the concrete design in the output part. If you click on the particular member, you can see the concrete design over here based on the required moment. STAAD is providing moment wherever the STAAD will consider the reinforcement details based on the required moment. So you might find the details quite different as we used on site, so it will quite different. So we will use required steel area for the calculation of the stirrups or number of bars calculation. So that we will do manually. We will not follow the STAAD Pro output concrete design detailing part. That means bar detailing we will do manually based on the required or the provided steel area based on the STAAD Pro. Similarly, you can go for the column part. If you click on the column, the concrete design will available with the load case, calculated load and moment, required steel area, percentage of steel, and the bar size. So this is how you can design it manually and check for the design parameters using STAAD Pro's 456 provisions of IS 456. See, we have provided only design beam and column command, and STAAD has automatically designed based on the check code or the codal provisions requirement. Thank you.